In this video for section 3.1, we're going to talk about how to graph quadratic functions in the form f of x equals ax squared plus bx plus c. And this is a little bit different than standard form because the vertex is going to take a little bit more work to find. But the advantage is that the y-intercept is very easy to find. So to find the vertex, first we have to calculate the x-coordinate using the formula negative b over 2a. So we plug in b and a, and then we figure out what the x-coordinate is. Once we get the x-coordinate, we plug that into our function, plug it in for x, to find the y-coordinate. And then we can plot the vertex. Now, the y-intercept is just c. So you can get the y-intercept just like we did in standard form by plugging in 0 for x. However, we don't really need to do that because we can see that if we plug in 0 for x, this is going to be 0. A times 0 is 0. This is going to be 0. B times 0 will be 0. 0 plus 0 plus c. And so a little shortcut we can take is that we can just look at the value of c. That's going to be the y-intercept. Once we have the vertex and the second point, then we can just draw in the parabola shape. And just like with the standard form on MyLab Math, you only need to plot those 2 points to get the parabola. So we're going to start by looking at example 3 in the textbook. It says to graph the quadratic function f of x equals negative x squared minus 2x plus 1. And so first we're going to calculate negative b over 2a to get the x-coordinate. Now, the book shows the negative sign kind of in front of the fraction. I find it easier to just put it on the b because when it's in front, it's kind of hard sometimes to know what to do with it. But if it's on the b, then it's just on the b. So the first thing I have here is that b is going to be negative 2. So when I plug that in, that's going to be minus negative 2, which is going to change to plus. So plus 2. And then for my denominator, we have 2 times a. Now there's just a negative sign in front of x squared, and that means that a is negative 1. And then we simplify this. We have 2 over negative 2, which equals negative 1. So my x-coordinate of my vertex is negative 1. Now I plug that in to the parabola function to get the y-coordinate. So I'm going to plug in negative 1 for x. So this order of operations here is a little bit tricky when you have a negative and then you also have a negative number that you're plugging in for x. Remember, you do exponents first. So negative 1 squared is positive 1. And then I put the negative sign. You can't make this a plus sign first and get 1 squared because that's going against order of operations. So negative 1 squared is positive 1. Put the negative sign on and that makes it back to negative 1. So we have negative 1. This is negative 2 times negative 1, so plus 2. And then plus 1. And that equals 2. So my vertex is negative 1 for the x-coordinate, 2 for the y-coordinate. So that's going to be right here. My y-intercept, well, that's easy to find. That's just the value of c. So the y-intercept is 1. So it crosses the y-axis at 1, which is right here. Now this parabola is going to open downward because a is negative 1, so a is negative. So I'm going to draw in the shape here as best I can. And it's going to look something like that. So we're still going to be asked in these questions in MyLab Math about the axis of symmetry, the domain, and the range. And this is the same as with the other types of parabola. So the axis of symmetry is x equals the x-coordinate of the vertex. For this parabola, my x-coordinate of my vertex is negative 1. The domain is always negative infinity, comma, positive infinity, parentheses around both. And my range, So for this problem, the parabola is going up to 2. The y-coordinate of 2 is the highest y-coordinate on the graph. So my range would be -infinity, comma 2, parenthesis around the -infinity because we always use parentheses around infinity, and the square bracket around the 2 because that point is included. So that would be my range. So next you should look at checkpoint problem number 3. Do this in your notes, check your answer, and then move on with the homework for the section.